Hello, you are most welcome. I'm teacher Ivan from Wunna Educational Services. I welcome you to our fourth lesson of vectors. In today's lesson, we shall be looking at the parallel vectors. What are parallel vectors and how do we tell that these vectors are parallel? This is the condition. Vectors A and B are parallel if vector A equals to KB, where K is a scalar or K is a constant. And this is what we mean. Assuming our vector A equals to 6, -10, and vector B equals to 3, -5. So we are saying that for A to be parallel to B, A should be equal to KB, where K is the scalar or the constant. So this is what we mean. If we substitute in A is 6, -10, equaling to K, which is 3, -5. So, can we find that value of K by simply dividing by 3, -5 by 3, -5? That gives us K as, but you notify that if 10 and 6 have a common factor, which is 2. So when we take out the 2, we remain with 3, -5 over 3, -5. And now these are the same. So that constant K, or the scalar K, equals to 2. And therefore, A equals to 2B. And since A equals to 2B, the two are parallel. So that is how we shall prove or show that the two vectors are parallel. For them to be parallel, one should be a multiple of the other. That is how we show that vectors are parallel. Then let us also look at the collinearity of the vectors. But before we look at that, we have some statement which is very important here. It states that in general, the vector KB is parallel to vector AB. And this certifies and confirms that for two vectors to be parallel, one should be a multiple of the other, or one should be equal to a constant times the other. So let us look at the collinearity of vectors. If, let's say, vector AB equals to KBC, where K is a scalar, then AB is parallel to BC. But B is a common, so B is common here and there, meaning B is in both vectors. So ABC then lie on a straight line. For instance, this is what we can do to elaborate that. We may have a triangle, and this is the origin. This is vector A, this is vector B, and maybe we have C in between. So you realize that these 3 points lie on the same line, and therefore, to show that these ones lie on a straight line, we must satisfy this condition, which says that AC should be equal to a constant K CB. 1, because SC equals to a constant K, CB, that shows that they are parallel. But 2, what shows that they are collinear is that they are sharing a common vector. So once we are able to satisfy this equation, that proves or shows that the two are collinear. Let's look at the examples concerning vector algebra. But maybe before we look at examples, we also have another important aspect to look at in vectors, that is proportional division of a line. Yes. For instance, we have a line with points A, B, but P is dividing the line in the ratio of 3 to 1. And therefore, that means that the ratio of AP to PB equals to 3 to 1. Then we might be asked to find the vector AP or vector PB. This is how we are able to do that. We have a straight line which is AB, but with a point B dividing it in a certain ratio, which we are given as 3, 1. And we are told that P divides AB internally in the ratio of 3, 1. What do we mean by the word internally? Internally means that point B is between line AB. Otherwise, if it was maybe somewhere beyond B, it could be externally. So that's what internally means. Then, if AP to PB equals to 3 to 1, the question is, how do I get vector AP? And maybe how do I get vector PB? Or even vector OP? This is what we shall be looking at, and maybe how to get that. I'm going to set a simple example on this. I will use a triangle from the origin. This is vector, this is point A with vector A. This is point B with vector B from the origin, and maybe the triangle is AB or AB. So, assuming we have a point E on line AB, but we can use any ratio that AE to EB equals to 2 to 3. Let's use that. So the question is, how do I get vector AE? How do I get vector EB? How do I get vector OE? This is where it is very important. So please be attentive. Now, how do we get the two vectors first of all? AE and EB. Now, from the ratio, this means that the AE over EB equals to 2 over 3. That's 1. 2, the other thing you must note is that we can get still the total ratio, which is 5. And therefore, if we want to get AB, let us get AB. AB equals to AO plus OB, but this is negative OA since we are reversing the direction, plus OB, which is OB minus OA. and therefore OB is B, OA is A. So that is AB. But when we look at our point E, which is dividing, point E is dividing AB into a certain ratio, and therefore that means that AB is also got by AE plus EB. But the ratio given to us is that AE to EB is 2 to 3. And therefore, if AE to EB is 2 to 3, then it shows that AE equals to 2 over 5 of AB, and EB is 3 over 5 of AB. And therefore, for us to get AE, vector AE, that is simply 2 over 5 of AB, which we have already got as B minus A. So this will be 2 over 5 of B minus A. And similarly, EB will also be 3 over 5 of B minus A. So that is how we get it. And maybe we might also be asked how to get OE. So we can imagine moving from the origin straight to point E. And therefore, OE is gotten by 2 ways. We can move from O to A, then from A to E. That is OA plus AE. Or we can also move from O to B and then from B to E. But if you are using this route, you need to be conscious about the direction. Our direction is from A coming to B. So if you are using this route, then you reverse, therefore it will be negative. And therefore, in this case, it will be OE equaling to OB plus BE, but BE is negative EB because originally it is from E to B. So it will be OB minus EB. So that is how we are supposed to do it. And maybe we now substitute, this is B minus 3 over 5 AB. So we substitute for AB, which is B minus 3 over 5 B minus A. So we open bracket and simplify. That is the proportional division of a line. Otherwise, that is internally. We also have externally when the line is divided externally. This is what we mean. So in our part B, we see that we have point 2 on the same line AB, but we outside the limits of AB or outside AB. So in case of a point that is outside AB, then we represent that ratio with a negative. The negative sign shows that QB is in opposite direction to AB because we are originally moving from A to B, but we are, in this case, we are moving from Q to B. That's why we represent it with a negative sign. So whenever Q is outside AB on either side, whether on this side or the other side, then HQ to QB will always be a negative. So that is proportional division of a line. So please don't miss out. In our next lesson, we shall be looking at various examples concerning vectors.